What's up, wonderful people? Richard back again with another video, and this is the Cyber Engine, a place where we keep you updated with matters relating to cybersecurity. And in today's video, I'd like to share with you guys how to code a Python Portscanner from scratch using the socket module. Without much ado, let's get right into the video. Okay, so now let's talk about a Portscanner. So a Portscanner is simply a tool for checking a server or host for open ports, and this tool is basically used by network administrators, cybersecurity personnel to identify ports and services running on a network or server. So to quickly demonstrate this with a well-known network scanner called nmop, let's see how this works. To show you this, I'll be scanning my own home network to see which ports are opened, closed or filtered. So an open port and a closed port already explains itself, but a filtered port just shows that a port is basically blocked from communication using a firewall or just a network issue. So to find out more about nmop, you can quickly type nmop with an argument of h, which will bring a lot of options with nmop. So let's scan our home network with nmop quickly. So my home router is on this network. So we can see that we have ports 53 and ports 80 open at the moment. So we can perform a full scan with the option -p- with a space. But this is going to take a lot of time. You can try that on your own. Now let's create our port scanner with PYTHON3 with the concept we just learned from nmop. So I'll go and make a directory for this project and use Visual Studio Code as my editor. So I'm already in my Visual Studio Code. Now let's create a virtual environment for this project. So a virtual environment in Python, as the name goes, to be virtual, works with the concept of a virtual machine whereby the installed operating system is separate from the main operating system, which runs in isolation. Okay, so this video is not about virtual environments. So I'll provide a link in the description below to direct you to an article I wrote on virtual environments. Okay, so now let's install our virtual environment with the pip package manager. F3, install virtual env. So with my PC, I already have virtual env installed. So I can just move forward and create a virtual environment with any name I want. So virtual env. I'll use a current directory as my name, so dot. Okay, so our virtual environment has been created. So now let's activate our virtual environment with the command source. In the bring directory activate. Okay, so we can see that our Python environment has been activated. Since this directory's name is fearless, it can be seen in this bracket over here. So remember to name your Python file with a .py extension. Alright, so let's go ahead and add a Python shebang. And a shebang is simply a special character sequence, mostly specified in a script, specify which Python libraries are kept or which program should be called to run the Python script. So we can quickly specify that using this path. We are in Python 3, so we are going to specify the Python 3 path. And so with this tool, we need a Python module or library called socket. So the socket establishes a connection on a network. So let's go ahead and import the socket module. So the more reason why we need this module is to establish a connection on the network. Okay, so now let's call a function in this module by creating an object, in the sense that an object is an instance of a class. So for the sockets library, with a variable called sock obj. So we can quickly create an object. Okay, so this socket function returns a socket object whose methods implement the various socket system calls. So this function has 4 default parameters, which is being suggested at the top over here. So we can specify this as family to be equal to socket dot. Then we would have to specify a host name or an IP address according to the parameters that are supposed to be provided for this function. So in our case, we just need the host name or IP version 4, which comes from the family of af_inet. And with the second parameter called type, just specifies the kind of socket you want. And in our case, we want the stream socket. So the protocol parameter also has to be set to 0 to select the system's default value for the given combination of family and then type, which in this case come in handy with the TCP, UDP and SCTP transport protocol. Moving on to the next one, which is the file number. If specified, the values for family, type and protocols are auto-detected from the specified file descriptor and returns the same socket, or just returns a -1 on failure. By default, all these parameters are provided, so you can decide to leave your brackets empty. So now let's accept input from a user by creating a variable called host. We are going to accept an IP address as an input from our user. Okay, now let's write a function to check if a port is opened or closed. And let's name this function Portscanner. So this only accepts one parameter, which would be our port. So with the condition of a connection using the connect_ex method, which returns 0 if an operation is successful, or returns an error message if unsuccessful. So let's call that on our instance we created at first. So if so, let's call obj. So let's provide this two parameters. If this is successful, if this is unsuccessful, which returns a 0, then you print what port is closed. Else, let it print port is open. We are getting closer to the end of our code. So now let's call back our function on an action of scanning the first 1,000 ports. Okay, so now let's check our code to see if we would have any bug in it. So with the aspect of printing out the port, we'd have to print out the number. So ports we can use a string interpolation in Python 3 to just call this F. Okay, so now let's run our port scanner and see if we'll get results on each port. But first, let's scan out just the first 100 ports. So 192.168.1. Okay, so that was a quick one. So we can see that port 53 is open and the rest of the ports are closed. So for us to distinguish between all these results, we would have to now add some colors to the results down here. So if a port is closed, we'd have to make the color red, and if it's open, we'll make it green. So we can quickly import the colored module from the 10 color library. So from 10 color, import color. Okay, now let's add that to our print statements. Okay, so now let's execute our Python Portscanner and see how that looks like. Okay, 192.0.168. That's one. Sorry. Okay, we just made success with that. Nice one, folks. We've been able to separate our closed ports from our open ports. Thank you very much. Thank you guys for staying till the end of this video. I'll be bringing an advanced form of this video, so stay tuned. Until the next video, stay awesome.